Hello friends, in this video we're covering ring dams. Now in the keyline books by P.A. Yommans there are actually a few variants of these ring dams, but they're all following the same principles pretty much, except that one of them is broken, meaning that it's open on one side so that it can be fed with feeder drains or water conservation drains, whereas the other ones, like this one that we have right here on the screen, they're completely enclosed, so those cannot be fed with any channels. You need to pump water to them. So this one is called a complete ring dam or just a ring dam. Then we have also a turkey nest dam, which is another kind of a ring dam that is completely enclosed. And then we have what is called the broken ring dam, which is partially enclosed. So let me show you a couple of images of that. So we can see again the complete ring dam on this picture at the bottom, and at the top we have the broken ring dam. Now in this video we're not going to cover the broken ring dams because they're kind of very similar to any of the other dams we covered so far. The only difference is that there is a flat undisturbed ground in the middle, and this is also the same for the other dams. But apart from that, they're basically the same as all the other dams that we've covered so far. For example, the contour dam would be very similar to this. It's just that when you're doing your excavation, you're not going to touch a certain area in the middle. Now, what is the actual, area that is left untouched? I couldn't find from the instructions in the books, so we can use some arbitrary value or kind of dimension for that area. Whereas the actual excavation takes part around the embankment, and then that flat undisturbed area is left in the middle. So we're going to do a complete ring dam, and then we're also going to do a turkey nest dam, and they're kind of the same. So I think the turkey nest dam, the difference with that was that there was no undisturbed ground left in the middle, so that's completely cleared. So those are kind of more simple in that way. Here we have in the book The Challenge of Landscape another diagram of the design of a ring dam. So this is the completely enclosed ring dam with the undisturbed area in the middle. So let's break this down to its building components. I'm going to take a screenshot of this image and paste it in our working document. So I'm going to move that right here and maybe expand the image a little bit so we can draw on top of it. And so the thing that I notice right away is that it follows the same basic components that the other dams have. We have obviously the embankment right here that encloses on all sides. Then immediately around it we have the excavation area. So all of this stuff right here is just excavated ground, and I'm not sure what is the depth of this excavation or what is the batters of it, but we can work with any arbitrary values, really doesn't matter. I would imagine that it's again maybe at least 1 meter deep below the embankment, and that the batters are 2-to-1, both for the excavation and for the embankment. Although I guess depends on the site. The embankment could be with a steeper batters because I would imagine these are very low embankments, so they will be more stable even with steeper batters. But of course the material is what's going to dictate this to a good degree, as well as other factors such as the compacting equipment, who is doing the compacting and under what conditions that is done, and so on. But for our purposes we're just going to use arbitrary values for that. Then for the undisturbed country, well, I guess this will depend on the site. Obviously, if we don't have a lot of space for leaving this undisturbed ground in the middle, then we'll just have to narrow it down to a smaller area. And the crest of the embankment seems to be very narrow, so I would put this to be around 2 meters to 2.5 meters. And he actually says here at the bottom that this intersection of the dam from one crest to the other is 900 feet in diameter, and then we have 12 feet of depth of water above the ground level. And so I would imagine that he measures it from here up to the water level, so that's 12 feet. But this is something that depends on the site, of course, in terms of the water depth. You can't necessarily secure the same water depth on every site. It's just looking at these as indications, of course, not kind of fixed criteria for our purposes. And so if we look at this cut section right here, we can see we have the embankments on this side and then the excavation right here. Then this is the undisturbed ground. And then we have an excavation on the other side and the embankment there. So this basically repeats all around. So let's find the site that we could possibly use for this. I think these being the absolute highest dams you can put on any landscapes, we need a fairly flat ridge to find a good site for those. So something very high up in the landscape that you could possibly pump water to, and from there you can reticulate it. And one detail that I kind of didn't touch on is that there's a lock pipe on one side, on I guess the lower side of the site. We're not gonna design these in our drawing because we already did that on other dams. It's basically the exact same thing. So we're gonna leave those out just for the sake of saving some time. And maybe I will probably dedicate a video specifically on grading the lock pipe trenches for any embankment, but I did cover this in depth in one of the videos on the Key Point Dam, so I might leave that out entirely. So let's start now by opening QGIS first and try to find a site. I'm going to use the DTM that you also have in your project files, which is the exact same one we've been using all this time. And let's quickly extract a contour map from this. So I'm going to select the DTM, go under raster, extraction and contour, and let's do a 1 meter interval between contours and run that algorithm. Now with that done, we can exit out of the algorithm and let's turn off the DTM and then select the contour layer and click here on the open layer styling panel. And let's set a black color for this so that we can see what's happening, or maybe a little bit of a transparent color. Let's also maybe double click on the DTM, go under symbology and change the render type to single band pseudo color, and just accept the default colors with the spectral color ramp and click on apply. Now these will be in reverse, so let's click on this drop down button here and choose invert color ramp and then click apply again, just so we can invert that. So let's look for a suitable site. We can see maybe right here we have something, but it doesn't look like it's very extensive, and so maybe let's look for something that has more space that we can work with. One thing that I forgot to mention is that this shape is not necessarily what we will be able to have. So this is very idealized version. What we are probably going to have is, you know, a more irregular looking shape. So instead of being a perfect circle, we maybe will have something, you know, like this, obviously with not so many wiggles, but kind of, you know, less regular. Basically, it may have a more irregular shape because for the most part, we have to loosely follow the shape of the site that we're going to build this on. So for example, right here, obviously if we build something that is perfect circle, then that will actually be in a negative for us because it doesn't fit very well with the geometry of the underlying geography. And so it will create a lot more fill material than necessary. So if we actually just loosely follow the geography of the ridge right here, we will probably get away with having to find more material. So I'm just going to quickly just observe here and try to find the site. So this one right here looks more or less okay, just about here. I'm just going to look around a little bit more. We possibly have another one right here. I think I'll go with the wider one that I found, which was around 100 meters. So was it this one? Yep. So maybe we will go with this one. So with that selected, let's create a new layer. Click here on the new shapefile layer button and call this boundary. We will set the geometry type to polygon and press OK. Then we will select this boundary layer and enable the editing. And then with the QAD plugin, we are going to use the rectangle tool for that and just make a kind of a rectangular selection right here, or not a selection, but a shape rather, so we can crop out this site right here. Now with that done, we can select the boundary, toggle out of the editing and save the changes. Then let's select the contour layer, go under vector, view processing tools and clip. For input layer, we will have the contour layer. For overlay, we will have the boundary, and we will run that with these options. Then we will exit out of the algorithm and hide the contours, the boundary and the DTM because we don't need them anymore. And this is the clip map that we're going to work with. Now from here, we should clean this map up before we continue, as we always do. So let's select the clip map and right click first and make a duplicate layer just so we can preserve the original in case something unexpected happens. Then select the clip map, and then let's first of all clean up any small noise that we have, like this one right here. So let's toggle on the editing. Go under the select features by expression tool, and in the expression field type $ length smaller than, let's try a value of 25 meters and click on select features. You will see this is going to select some of the noise, but it does select also some of the contours that we do want to preserve. So maybe let's reduce this to 15, even that's too much, maybe 10 or even 5. There's not a lot of noise on this map actually, so that's all right. And with that done, we can actually, maybe there's a little bit more. Let's go with 10. Yep, this one got selected now. Now let's close out of this and we can zoom in here. And then let's go back up to select features. So select this tool, then hold the control button and make a marquee selection, just the left mouse button holding and dragging out to make a marquee selection, and select these contours, holding the control button. So this will deselect them basically, so we don't delete them, because I don't want to delete these major contours. I just want to get rid of the noise. So we can also do that for this one on the edge right there. Again, just holding the control button, left clicking and dragging out the selection, you can deselect those. Let's also zoom in here and see what's happening with these ones. Okay, that's all right. We can delete that one. We don't need it. With that done, we can then just click on the delete button right here, delete selected, and that will remove them. The next thing we should do is to toggle out of the editing and click to save the changes. And then with this contour layer selected, let's type simplify in the bottom left corner of QGIS. There's the search field. And then double click on the simplify tool. And then for the tolerance on this algorithm, we're going to use, I think 0.5 will be enough. Simplification method will be set at distance, and then we will click on modify features. So this will remove many of the unnecessary vertices or points on these contours. Then let's close out of this algorithm and zoom in here to see how many vertices are left. So this looks pretty good to me. It didn't remove too many points. It removed just enough, so we can work with this. And another thing we should do while the editing is still toggled on is to go back to the select features by expression, and in the empty field here type geometry is null. So we will use this basic script to select any geometry on this layer that may be empty, because that can cause issues. So just click on select features. In this case it didn't find anything, so that's good. Then finally let's select this layer and toggle out of the editing and choose to save the changes. Now we can rename it. So right click, choose rename, and let's call it contours-1 meter. And then we can right click and choose export, save features as. I will export this as SRE shapefile and uncheck ID and FID because I don't need those inside of Civil 3D. And I will uncheck add save file to map, and then click on the ellipsis button under file name. I will save this to your project files for the ring dam video, and I will call this the survey data folder, as all the other ones are also called like that. And this will be contours underscore or other dash 1 meter. And it may also be a good practice to put the EPSG code 32756, which we can see in the bottom right corner of QGIS, and also under the contour layer itself. Then with that done, let's press OK and export this out. And then we can go into Civil 3D. And as always, the first thing we're going to do on this brand new drawing is to georeference it. So let's click on the coordinate system button on the Spatial Manager plugin. And for the coordinate system, we're going to use 32756, which is the same one we just exported the contours at. Click select on that, and now the drawing is georeferenced, so we can bring in the contours. Let's click on the import button. You can also use the other georeferencing approach that I've covered in other videos, as well as the other importing approach, which I've also covered there for shapefiles. So you can check out the importing data module. I'm going to now navigate to where the files are, which would be under the storages chapter, survey data, and there are the contours. Then I'll click next. The first thing is to check the elevation tab. So just make sure this is checked on under general options, and then select the elevation attribute. And for the name, I'm just going to call this 0-contours-1 meter. And that's about it. Now you can click finish. So this should import the contours and we will be able to see them here. If you did get an error here, that's okay. You can ignore that. Just click close. And so here are our contours. The very first thing to check is whether the elevation data is really there, just to be sure. Select one contour, right click and choose properties. And we can see right here we have an elevation value, so that's a good sign. Now we can select all of these contours just by either pressing Ctrl and A or just left clicking, holding and dragging out don't hold, just left click once, then drag your cursor out and left click again to make a marquee selection. We will create now a new surface just by right clicking on surfaces under the tool space and choose to create a surface. And let's call this under name existing ground. Then the style, we can change that to 1 meter and 5 meters just by clicking here under style on the ellipsis button, and there is a preset called 1 meter 5 meter background. Let's select that and press OK, and then OK again. Now let's expand surfaces, expand existing ground, and expand definition. We need to tell Civil 3D what to use as a definition to create this 3D surface. So in this case we have contours, so we can right click on contours and choose add, and our contours are already selected, so it will detect that. The only thing we need to turn this on is swapping edges. So we will turn that on here and press OK. And now it will create the 3D surface. There it is. So you can know it's a surface because it's outlined by this green boundary. We can also check it out in the object viewer just by right clicking on the existing ground surface. Choose select and then right click anywhere on an empty space in Civil 3D and choose object viewer. And now if you just left click, hold and drag out your cursor, you can preview the surface in 3D. If you release the left mouse button, it will show you the shaded model, which you can change the style of here from the drop down menu. So this looks pretty good. I don't see any artifacting or weird anomalies happening, so we can work with this. Let's exit out of the object viewer just by pressing escape. And the first thing we should do is to set up our layers. So under the home tab, let's click on layer properties here on the far right. This will open up this window for you. Let's hide the contour layer because we don't need to see it anymore because we already created the surface. But we can create a few new layers just by clicking on the add new layer button. The first one will be called 0-embankment. Then we will have 0-borrow pit for the excavation pit. Then 0-water level. Remember, we're not going to have a spillway on these dams because normally we will have a layer for the spillway, but because these dams do not have a spillway, except for the broken ring dam, which does have a spillway through the water conservation channel that connects to it. These other ones, the turkey nest and the complete ring dam, do not have a spillway. They just have a lock pipe that is basically used as a spillway. So we're not going to have a spillway layer. We just have the water level, borrow pit, and embankment. I'm going to double click on the color for the embankment and just choose a yellow color for that. For the borrow pit, so I'll have the magenta color, and for the water level, a cyan color. We are ready to start laying out our dam. So I'm going to first switch the layer to the embankment layer because that will be the first thing that we're going to lay out. I would imagine that these dams have at least a 0.5 meter freeboard, but these dams, because they do not have any runoff coming into them and they're kind of small, so there's not a lot of wave action, I imagine that you don't really need a very large freeboard. So I would guess that originally they would also have been designed with a smaller freeboard with around 0.5 meter, and maybe there is even somewhere on these drawings kind of an indication of the freeboard, but I honestly don't see anything. Let me check this one. Yeah, so I honestly don't see any indication of what the freeboard is. I would imagine that we can go with a smaller freeboard of 0.5 or 0.6 meters. So I'll go back to Civil 3D, and now we have to start laying out the shape of our dam. Now we can grab like a circle from here, and you can either choose a radius or a diameter for how you want to draw this out. It doesn't really matter, but if you want to make a circular dam, you can use that too. So you can see how it doesn't really fit very well with the geography of the underlying landscape. So I would imagine that probably a better way to do this is to at least loosely follow the kind of the geography of the underlying landscape. This is what I'm going to do. I'm going to grab a polyline and then loosely follow the shape of this contour right here. So that will be contour let's see, this is 699, just because I want to make the dam a little bit bigger. We can also go with this one, 698, if we want a larger dam. So let's try this one. The issue with going lower in the landscape is that obviously the embankment will have to be much higher. So the lower you go, you have to have a larger embankment, higher embankment, because obviously otherwise the landscape above is going to take away a lot of the storage just by being in the way there. So it's probably best to be as high up as possible with your embankment, but this will depend on the underlying geometry or geography of the site. If you have a very flat ridge that is kind of very large as well, that will be ideal. In this case, we do not have that. It's a rather steep ridge, but we can work with what we have. So I'm going to start right here completely arbitrarily. Just I'm going to snap to this contour just by using the snapping tools and use that as a starting point. Now, you don't really need to snap to the contour, but just to have something to start off with. And again, very loosely follow the shape of the contour. You can see the angles are kind of triangular or angular. And I don't want to snap to each and every wiggle right here because it's going to create issues for the geometry of the embankment. And then I think we can actually right click and choose close right here to close that shape up. And then maybe let's take this point and position it here, something like that. Then I'm going to toggle out of the snapping options. And now we're going to use the fillet tool to fillet all these angles so that the embankment is more rounded. So let's click on fillet. And first let's click on radius down in the command line. And let's experiment with a 50-meter radius. And then click on multiple. And I just want to see if this is actually a good radius or if it's too much for some of these angles. So you can see it says here radius is too large. So let's go down to 40 meters and see if that works. I'm just gonna experiment on each angle here. Now the radius doesn't have to be the same for every angle, of course, but just for simplicity's sake here. Yeah, so this seems to work. We can use that. So I'll select the fillet tool and it will remember the radius we've chosen, which is 40. So I'll just click on multiple and then start clicking on these segments one by one, just to fillet all of them. You can see right here, it says the radius is too large. So another way we can do this is to bring the radius back to 0. And let's make a 0 radius between these two entities. And then instead of clicking on this segment and then on this segment, we can go straight to the next segment right here. And then maybe let's reduce the radius a little bit to 35 and then bring it back to 40. This is still too large, so let's do 35, 30 for this side. And then we can do 40 again here, or maybe 30 again. It sticks a little bit better, maybe even 20. This one we can increase a bit to 40. So that's pretty much the shape of our embankment. Now we can right click and press enter. So we have to choose how high do we want the embankment to be. Currently, the highest elevation that we have on this site is 701 meter. If we leave, let's say, everything between 700 and 701, so this whole area right here, we can leave that as that undisturbed ground. So we would want our embankment to be at least half a meter above this. So we could try to place it at elevation 701.5 and see if that works out okay. Also, the top of the crest of the embankment, I think I'm gonna go for a 3 meter just to experiment and see how that looks. So a 3 meter width for the crest. So let's grab the offset tool and then specify a 3 meter offset and press enter. And then grab the layout of the embankment. And I think in this case I'm going to offset outwards, so towards the left hand side, and left click there. Now we can grab these two lines and convert those to feature lines. So we will select both of them and go to feature line and then choose create feature line from object. And we want to create a new site for them. So I'm going to click on the create new site button and call this embankment and press OK. We will not erase them for now, we will just assign elevations and we'll press OK on that. The elevation will be 601.5 as we just discussed, and we'll press OK on that. Now I'm going to grab these two feature lines and just select also the surface, right click and choose Object Viewer, because I want to see how these look together when we preview them. So you can see the embankment is sitting just above the top there. That looks okay. Let's press escape and see how it's going to look when we grade the embankment. I think for the batters maybe we can go for 1 to 2s. So let's select the grading tools and choose grading creation tools. And the first thing we need to do is to create a grading group like all the times before. So we're going to click on set grading group, choose the embankment side and press OK. And then we will type embankment for the name, choose automatic surface creation and leave it at the default contours 1 meter and 5 meter design, and choose volume based surface, the existing ground. And then we'll press OK and OK again. And now we will choose to grade to surface and then click on create grading. Now we can first of all grade the external batter. So let's click on the external line, choose the feature line. Let's left click on the left hand side and apply to entire length. We're going to use slope at 2 to 1 and for fill also slope at 2 to 1. Let's see what happens. So this is the external embankment now created. Let's repeat the process for the internal one. Let's select the internal line, left click towards the internal side, apply to entire length at slope at 2 to 1. And finally we have to fill in the middle of the embankment because it's empty. So let's choose to create an infill and then just left click in the middle. It's going to be highlighted for you, so just left click there. So now we can select the embankment, right click and choose Object Viewer. Let's see how that looks. So that's basically how the embankment looks. We can also view this in conjunction with the surface. Let's select both of them and you can see how that looks. So again, we're leaving this middle area undisturbed. We're just going to excavate around the embankment itself, and I imagine that will be done either following the geometry of the underlying landscape or just a specific width of that excavation. So I'm not honestly not sure because I don't know the exact details of how Yeomans would have done these, but I imagine he would have done either one of these approaches. I think I'm going to use the second approach, just make a regular offset from the edge of the embankment, and that will determine the width of our excavation. And I will try not to go with that offset to a point where we actually cross this contour for the elevation 700, because again, I want to leave this undisturbed, all of this right here. So our offset will probably extend up to right here somewhere. Let's switch to the borrow pit layer and choose a polyline. And now we want to roughly trace out the embankment. We can use the snapping tools for this. So just enable snapping tools, and we're going to use the endpoint mostly. So I'm going to snap to, you see where we have these lines crossing the embankment? There are points right there. So if we snap to these, I would imagine this will be okay. We can later create curves between these segments. So we don't need to worry about that now. So I'm just going to snap to these points. You can see it's not at all precise. And then we're going to right click and close once we do that. Then let's grab the borrow pit line and then hover over the segments. And you will see that you have the option to convert this to an arc. So let's choose that and then just snap to the embankment right there. It's okay if the arc goes a little bit into the embankment, that's fine. Also snap right here for this one. And just one right there, or rather right here, the innermost point. And we have another one right here. something like that. Now we can take this and convert it to a feature line, and then we will create our offset from it. So I will select the borrow pit line, go under feature line and choose create feature line from objects. Now we need to create a new site again. Let's click on that button and call this borrow pit. We will not erase it, just assign elevations, and we will pick up the elevations from a surface, but do not insert any intermediate points. The surface we want to choose in this case is the embankment, so we're going to select that and press OK. Now we also need to create a new grading group, so let's click on that button and switch to the borrow pit site and choose to create a new group, and we will call this borrow pit again. And we will have a volume-based surface, which is the existing ground in this case. So let's press OK on that and OK again. OK as well. So first of all, I think we need to grade down. If I go to the document, so currently we are at this point right here. We have created just a single line around the edge of the embankment. What we need to do is to grade down to an exact elevation, and we will do this at a slope of 2:1, and only then we will create the offset, and then we will grade upslope to the surface again at 2:1. So I think that is probably how it's going to work. So to determine this elevation to which we need to grade down, we can just take the bottommost side of the embankment and go down 1 meter from there, and that will give us an elevation that we can work with. Of course, depending on the project, you can go deeper than 1 meter, but we can start with 1 meter for now. So let's go back to the drawing, and now we need to select the innermost side of the dam, which would be, I believe, that would be this feature line. Let me check the, yep, so you can see once you select the feature line and go to the properties just by right clicking and choosing properties, under the data section you have site, and there it will tell you which site this feature line is on. This is on the embankment, so we know this is the embankment feature line. Now notice also it says the minimum elevation is 698.231. So if we go 1 meter below this, it will be 697.231. We can also go maybe 30 centimeters deeper than that, just to account for any stripping of the topsoil, as I mentioned previously in other videos, but obviously that would also depend on the site. Maybe you don't have 30 centimeters of topsoil, but just to take some value in this case, so arbitrarily we can use 30 centimeters. So it will basically be down to elevation 697 if we were to round it up. So we can use that just for simplicity's sake. So let's switch the mode here to grade to elevation and choose to create grading, and then click on the feature line, and then we want to grade towards the interior. So we're going to left click there and choose to apply to the entire length, and we will choose elevation 697, and for the cut format we will choose slope at 2:1 and fill slope at 2:1. So that created that grading. Now we need to grade to distance, so let's switch the mode to grade to distance, and we can do a completely flat bottom. We don't have to have any slope on that, so let's choose select the create grading option and grab the innermost feature line, choose to apply to the entire length, and then we have to choose a distance. If you just move your cursor, it will tell you kind of the distance or how far you are from the edge of the line. Now we can see that at around 10 meters or so, or up to 12 meters, it seems to start rubbing against the edge of this here that we want to preserve. So maybe we can do something like a 10 meter. So let's type 10 and press enter. And instead of using slope for the format, we should choose grade, because grade is the only option that will allow us to do a flat bottom. So let's choose grade and then type 0. And then this will give us our 10 meter offset. It is actually a little bit too much. It starts interfering with the top that we want to preserve. So let's go back to our grading creation tools and choose to edit grading, and then just left click on the grading that we just made. And instead of 10 meters, let's type maybe 7.5, and again choose grade at 0. Okay, it did the processing, but it looks pretty bad. Something is completely gone wrong here. So let's select the delete grading option and just left click on the grading here, and maybe redo the original grading down to the elevation 697. So I'm not sure why it did that, but let's do it again. Select the feature line, and before I do that, let me just check. Select the feature line and click on elevation editor, and this will bring up the panorama. So just make sure you don't have any blank elevations, because it could be that it's getting confused because of that. Didn't see any, so let's go back to grade to elevation, feature line, and then select the grading side, apply to entire length 697 at slope of 2:1. So this is looking good. I don't see any issues. Now we can choose grade to distance and try again. If that doesn't work, I'll show you an alternative way. So let's do 7.5 meters. Format will be grade at 0%. So again, it seems to be slowing down. For some reason, it's doing a lot of calculations, which is really odd. So you can see it didn't actually do anything. Okay, so we can do an alternative way. Let's select the feature line. Actually, what we need to do is to trace this feature line first of all. So let's select the Home tab and switch to the polyline tool, and then just quickly go around and again trace the feature line just like before, just very loosely. And once you get towards the end, right click and press close. Then just like before, grab the segments, and you can press Ctrl twice. So once will let you make new points. If you press it again, it will let you convert the line to an arc, and that will allow you to grab the segments and quickly convert them to arcs, and then you can snap to the feature line. So just go all around and convert all of these to arcs. Now with that done, we can offset this line. So let's grab the offset tool, and now let's do our 7.5 meters. So type 7.5 and offset towards this side, just left click there. And that looks just about right, I guess. We can leave it at that and experiment to see what happens. Maybe actually 7 meters will be better. So let's select the line again and do 7 meters instead. And we can delete the outermost line. With that done, we will convert this line to feature line and place it on the same site. And we will place it at elevation 697. So basically we're doing the exact same thing that we wanted to do with the grading tools, but because they didn't work, we can approach this differently. So if I go back to the document, like before, we already have this line right here, and we already created this grading down to the elevation right here. What we don't have is this line right here. We couldn't create that because the grading tools were misbehaving. So instead, what we're creating is this line manually on the other side. And now we will place it at elevation 697, the same as this elevation right here. And then because they are on the same site, they will be able to see each other, and they will automatically connect to each other like that. So this grading here will be automatically created, and they will create this kind of a flat plane. And also then we will, actually, I'm sorry, I explained this incorrectly. We started this line right here. So we haven't actually created this batter right here. So now we just offset it and created this line at this side. And we will place this at elevation 697, just like this side right here. Then, because we put them on the same site, they will connect to each other and they will create a flat plane. And from there, we can grade upslope to the surface at 2:1. So I'm sorry about that confusion. We didn't start the line here. We actually started it right there. So let's go back to Civil 3D and create a feature line from this. Again, it's important that they are on the same site, so this will be on the borrow pit site. So we are basically placing them in the same universe so that they can interact with each other. If we place it on the embankment site, they will not be able to interact with each other, so that's really important. So let's place it there and assign elevations. We're not going to erase it for now. We're just going to press OK on that and switch to elevation. And we know the elevation has to be 697, the same as the bottom of that grading we created earlier. And we'll press OK on that. They will not automatically create the surface. We need to infill, because this area right here is now empty. So if we go under infill, you can see it's going to highlight it. So we can left click there and then press escape. And this will create the grading just like that. So if we select this surface now, right click and choose object viewer, you can see this will be basically a flat plane. So this is one way to circumvent grading tools if they don't work for you. Bear in mind that you can create any kind of grading using only feature lines. You don't actually need to use the grading tools. They just make things a little bit easier, but if they don't work, you can use this approach instead. Now what we're going to do, now that we have created this plane right here, this bottom, all we need to do is to grade up to the surface on that side on which the undisturbed ground is. So let's choose grade to surface, choose create grading, and then we grab the innermost feature line, and then We want to grade towards the interior. We apply it to entire length and choose slope at 2 to 1 and fill slope at 2 to 1. And let's see what happens. So this doesn't look too bad. It does disturb the ground there a little bit, but otherwise it looks fine actually. Let's create a new surface and go under surfaces and choose right click there and choose create surface. And let's call this final ground. We can leave the style the same, just press OK on that. Then expand final ground and expand definition and select edits. And now right click and choose paste surface. And we're going to start pasting our existing surfaces into this final ground surface, starting from the bottom up. So first of all, we're going to have existing ground, then borrow pit, and finally embankment. So let's choose the existing ground first, then right click again and choose paste surface, paste the borrow pit, and finally paste the embankment. And I actually pasted the borrow pit twice, so let me remove that and paste the embankment instead. I'm going to right click on final ground and choose to rebuild automatic, and then right click again and choose select, and then right click and choose object viewer. Now you can see how that looks, and currently it is empty in the middle. We have to fix that up. Let's infill the middle because I forgot that it's actually still empty. So we need to go to the grading creation tools, being already on the borrow pit group, and choose create infill, and then just left click there in the middle. And now if I select both of these surfaces, we should see that the middle is actually flat. And now we can go back to the final ground and go under edit, and then click on right click and choose base surface. And just like before, we will start with the existing ground, but this time the borrow pit will be at the top. So our embankment is going to be last. It's going to be next, and then the borrow pit is going to be last. It's very important in which order you paste these surfaces depending on the dam design. Obviously, it's very uncommon that the borrow pit will be last, but in this case I think we may have to do that this way because the borrow pit is actually sitting at the very top. And so there we have it. Now it looks a little bit more accurate. I still see a couple of issues. First is these seams. And this is why the borrow pit usually goes, the embankment usually goes last, because the embankment tends to sit on top of everything, so it does cover these seams and it ties everything together. But in this case, I think if we try to do that, I'm just going to quickly try and do that. It's not going to work. It will leave us with an empty hole in the middle. But let me just try again. I'll just paste the borrow pit and then paste the embankment last. Then select the final ground and choose object viewer again. So let's right click and delete everything except for the existing ground and reorder things again. And this time the embankment will go first and the borrow pit will go last. Now let's check this again, and maybe we can think about how to fix those seams. Basically what we will have to do is to make sure that the borrow pit is well connected to the embankment, but otherwise it doesn't look too bad. This is enough for a decent volumetric analysis. So I'm going to right click on the final ground and choose surface properties, and then switch the surface style to no display and press OK on that just to hide it temporarily. And then I'm going to zoom in here into the borrow pit and select its feature line. And I just want to see if everything is well connected. So I think this is the feature line of the borrow pit. We can confirm this by right clicking and going under properties. And we can see the site is the borrow pit site. So that's fine. We just maybe need to move this a little bit further in. And it may help to turn off the snapping options by pressing F3. And then we can move this a little bit further in to the embankment. And this should automatically update any other surfaces that are related to the borrow pit, such as the final ground. Actually, it's a good idea to turn on the snapping and then try to snap the feature line to one of the embankment's contour lines, just so that their elevations tie in together, because they will pick up the elevations off of each other. So I'm gonna snap them to the red line basically, and then we will see how that is going to look. When you're doing this, just make sure that you save your drawing often, because it's going to do recalculation of the surfaces on every point that you move, and there's always danger that something will break. And just to see if everything works better now, I'm gonna right click on the final ground, choose surface properties, and bring back the 1 meter and 5 meter style. Press OK. Then right click on it again, choose select, and then right click and choose object viewer. And now let's zoom in here. And for the most part, we corrected the seams right here, but there's still one seam right there, so we can quickly fix that one. Now if we select the final ground again and preview this, okay, it's still there. It's actually right here, you can see it. So that's the seam there. Now I believe that this would probably be fixed. So let's select the final ground again, go to object viewer, and for the most part it's fixed. There's a little bit left there. So that's, I think, this one. Now let's preview this. So you can see now it's pretty much gone. And that looks a lot better. It also fixed some of the artifacting on the embankment itself. So I'm happy with that, and I think I'll leave it like that. Just to quickly mention how we would do a turkey nest dam, which basically means removing the undisturbed ground in the middle. It will be completely flat. I'm gonna actually save this drawing now as a ring dam, and I'll make another copy of this and call this turkey nest. And in that one, we can redesign this a little bit just to make it completely flat. So it will be very easy. All we have to do is to go here under edit grading and choose delete grading instead. And all we want to do is to basically delete the grading for the borrow pit. So just delete everything. And we can also grab the interior of the feature lines there and delete that as well. So basically the only thing we need to do now is to infill the middle. So just create an infill and left click in the middle, and this will create a completely flat plane. So if we select this now, you can see that looks completely flat in the middle. So that's a turkey nest dam basically. It doesn't have the undisturbed ground in the middle. And yeah, that's basically it. So you can quickly convert a ring dam to a turkey nest dam. And now the last thing that we may want to do is to just export this out maybe to something like Google Earth. So before you do that, just make sure that you save your drawing. So I'm going to save this again under the turkey nest. And from here, what we can do is just maybe select the final ground surface if that is what we want to export. And then with that done, we can type explode. And then again, we can select it. It's going to be a block reference after the first explode, so that's okay. Just select it and type explode again. And this will convert everything to just basically polylines. And so with that done, we can now select all of this and export it out to Google Earth. So just grab everything, and then in the Spatial Manager toolbar, you can click on Export to Google Earth. It will say that it's not going to export certain objects. That's okay. It's not going to export the borrow pit and the embankment and the existing ground because these are special Civil 3D objects. It's also not going to export any feature lines and any grading objects. But that's fine because these are the ones we don't want to export. We just want to export the final ground, which we already converted to simple polylines. So it's going to automatically select just that. And then we will press OK, leave it at only selected objects and press OK again. And I'm going to put this again in your project files under ring dam, under the folder called exports, and this will be called turkey nest. And with that OK, you can just click on open in Google Earth. And so there it is in Google Earth. This is the turkey nest variation. It did preserve the borrow pit outline and the crest outline. Another thing we may want to do is to also measure the volume of this. So let's go back to Civil 3D and measure the water volumes, the embankment volume, and the cut volume from the borrow pit. I'm going to undo the exports just to bring back the surface, the final ground surface. So just press Ctrl and Z until I see that appear. And now we need to create the water outline. That will be at elevation 701, which is right here. So we, again, remember we have just half a meter of freeboard. Our crest is at elevation 701.5. So our water level can be at elevation 700. I'll switch the layer to water level and take a polyline and then just trace out this one contour here. This red line is actually elevation 701. So the water level has been outlined now, and we have to convert this to a feature line. So with that water level line selected, let's go to feature lines and create feature lines from object. We need to create a new site for this, and we will call this water volume and press enter on that. We will not gonna erase the entities, just assign elevations. And again, this will be at elevation 601, and we'll press OK on that. Now we need to create a new grading group, and we will call this water volume and place it on the water volume site. Now, very important here is to choose volume-based surface and choose the final ground, not the existing ground. Choose final ground and press OK, OK again, and OK again. And the only thing we need to do is to infill the middle. So let's grab an infill and just hover over the middle and left click there. And this will fill the surface there with volume. Now let's type report surface volume and press enter. And this will bring up the panorama. We need to create 3 entities here. So just click on this first button on the top left. And the first one will have a base surface for the existing ground, and then the comparison surface will be embankment. The second one will be existing ground and borrow pit. And finally, it will be final ground and water volume. So we can see right here that the embankment has a fill requirement of 11.8 100 cubic meters. Then the borrow pit provides only 13,000 cubic meters, so there's a shortage there. We could remedy this by just digging in deeper, so that's one way to fix this. And the water volume is actually 21.8 megaliters, so not too bad. One thing you may want to do is to also increase the fill factor for the embankment, just to account for any settling of the material. So a good number to go with usually is between 10 to 30%. We can use 10% in this case. So if you just type in 1.1 here under fill factor, it will give you an adjusted fill volume. And you can see that's 13,000 cubic meters against what was previously just 11,800. Ideally, your borrow pit is going to provide for the adjusted fill, not for the one that is without the settling rate accounted for. Of course, if the project permits, so all of this depends on the objectives of the project and the budget of the client and so on. But assuming that it is allowed to do it and it is actually physically possible, it's possible to dig deeper on that site. All we have to do is to switch the grading group to the borrow pit, press OK on that, and then click right here and choose Edit Grading. And then just left click on the borrow pit, and instead of elevation 697, let's maybe try 696. So instead of 1 meter, we're going to do 2 meters deep. Press enter. The slope for the fill and cut will stay at 2 to 1. And then this will recalculate everything. When you press escape, this will also update the other surfaces. Now we can open up the panorama again. And all you have to do is to click the refresh or recompute volumes button. And you can see now the borrow pit was updated to provide a lot more volume. So this is just too much. We can come back here, choose edit grading again, left click on the borrow pit, and let's try 696.5. But basically we'll just use this back and forth process to adjust the borrow pit volume. You can see this is even too much again. So maybe we have to do 696.7 or something like that. maybe 75. And let's recompute again. We're getting there, maybe 696.85. Yep, so something like that. It's good to have a little bit of surplus. And so this is it, basically how you grade a turkey nest or a complete ring dam. Thank you for watching, and I hope this has been useful. I'm going to save all of these files to your project files, including anything that we have had inside of QGIS, the DEM, and the boundary as well. So you can use the exact same boundary and contours and everything that I've been using in this video. Again, thank you for watching, and we'll see you in the next session.